All right, next. This is uh, this is another interesting thing that we can do with law of cosines. It has a little bit more versatility. Notice we're kind of not in the best shape here. We have three sides, no angles, and if we're going to solve this triangle, we need to find any angle. Then we would have a pair. Whatever angle we'd find, we'd have a pair, and we could use law of sines. And then things kind of deteriorate fast for us, and it unravels, and we can solve it quickly. But the law of cosines in this way isn't the best. So here's what happens. We should solve the largest angle first. And it's just because down the road, when we need to use law of sines, we want to avoid any possibility of getting the ambiguous case, or getting, if we do it one way, we get one angle, one answer for an angle, and if we did it a different way, we'd get a different answer, and we want to avoid that. So just solve the largest angle first. How do we know which the largest angle is? It's got to be opposite the largest side. Like this angle right here opens up to create this side, and so this has to be the largest angle. So I'm using law of cosines to find angle B. So what that's going to look like is, I know that B, side B, has to be on this side. This is 24.3 squared. And I can start filling in the rest. I also know already that cosine of B has to be over there. These other two are interchangeable. So you could use 19 first if you wanted, or 21.8 if you wanted first. 19 squared minus 2 times 21.8 times 19. This we should go a little bit step by step. You scroll down. Just because the solving is a little uglier. You just have to be careful. You can't skip any rules here. They're all gonna matter. So 24.3. Let's see what that is. Squared is 590.49. 21.8 is 475.24. 19 squared is 361. And I am going to just multiply these three numbers together because they can all be multiplied, but cosine B is the variable solving for, so kind of stuck right there. Anyway, that's 2 times 21.8 times 19. This is 828.4 cosine of B. Now, a lot of times to solve this, what people end up doing is they add these three numbers together. That's the most common mistake. You can't do that. You can add these two numbers together. They're like terms. This one's not. Cosine B, you can think of that as like your variable. B is your variable, but cosine of B certainly, you can't do anything with it. So this is attached to your variable. You can't. It's not like terms with the rest. So you can add these two, which is 475.24 plus 361, and we get 836.24 minus 828.4. Just rewriting it. The next most common mistake is they subtract these two. You still can't, because cosine of B is attached to this number. You can't separate it yet. So we're gonna have to get rid of this number, then detach this, and we can unravel from there. So we're gonna subtract 836.24 from both sides. So this is 590.49 minus 836.24. And I got negative 245.75. Keep in mind that over here, what's left over is a negative of subtraction. So you have a negative 828.4 cosine of B. Now we're almost there. We can get cosine of B by itself if we divide by this number. So we'll do that to both sides. So our previous negative 245.75 divided by negative 828 0.4. And you should get some decimal here. I got 0.2966656. Writing all these out just because I want to maintain some accuracy, so we don't all get different answers. 62047. Ideally, we'd use significant figures, but now this is cosine. It's equal to cosine of b. The way that we get rid of the cosine of b is by inverse cosine the other side. So now we're cos inverse of all of this 0.2966656, all that stuff. That's what b is equal to. And we can get that. And I get 72.7 degrees, I suppose. So we did a lot of the hard work. That's the hard part with when you have side of knowns, to use law of cosines to find an angle, and specifically we find the biggest angle when we have to solve a triangle first. So 72.7. We know something great now, because if I know that this is 72.7 and I know its opposite side, we can use law of sines. Sine 72.7 over 24.3 is equal to either one at this point. We found the biggest angle, so I guess I will keep it consistent and do the next biggest, sine of c over 21.8. I'm going to do work on my calculator, save a little bit of time, but really we're just cross multiplying. You get an equation. You get 24.3 sine of c is 21.8 sine 72.7. You should be able to solve it from there. We're going to get eventually c is equal to, I'll divide by 24.3 here, and then inverse sine. So inverse sine of all of this is going to be 21. Inverse sine of 21.8 times sine 72.7, and then it's divided by 24.3. And again, I'm inverse sining that, and I get a 58.9 degrees. We should be able to then very easily figure out angle A. They all have to add up to 180, the angles, the interior angles. So 58.9. And then I get 48.4. So that's a beast. It's always rough when you have side, and you're trying to find an angle. You have to use law of cosines, and it gets a little ugly, as you can see. And it's just the only reason why this is more difficult than the other one is because we had to solve for the variable. We had to solve for cosine of b, so we had to get all this junk away to the other side, and then inverse cosine.